Okay, so today's topic is milk replacer. Milk replacer, it is used when the milk is produced by a dam is used for commercial purposes. For example, selling the milks for human consumption, or making some, or creating, or producing some milk products. So milk replacer, it is used when the milk is produced by a dam which is used for commercial purposes. Okay. The constituent of milk replacer are whey protein, D-lactose whey, casein, and dried skim milk. Okay. So whey protein, what is whey protein? When we coagulate the milk and we get the white portion, coagulated white portion, that is called whey protein. D-lactose whey means we remove the lactose from the whey. Casein is the milk protein, and dried skim milk, that I don't know what it is. Next is alternative protein sources of milk replacer. So milk replacer, sometimes proteins of, that is casein, can be replaced by soya protein and wheat protein. The classification of milk replacer, there are two types of milk replacer: all milk type and alternative protein type. All milk type contains only casein, that is milk protein. Okay. All milk type, this all milk, so contains only casein, that is milk protein, and all alternative protein type, 50% milk protein, that is casein, and 50% alternative protein, that is soya protein and wheat protein. Easy? Okay. Now if the percentage of alternative protein is more than 50%, then it is called milk substitute, not milk replacer. Okay. Okay. Now when we have to use which type of milk replacer? So at first 3 weeks of age and after 3 weeks of age. First 3 weeks of age we should feed only all milk type of milk replacer. After 3 weeks of age you should feed alternate type of milk replacer. Okay. So why we are focusing on 3 weeks? Why specifically 3 weeks? So specifically 3 weeks because of the fact that rumen development takes place from 3 weeks to 3 months. Okay, that is why. Before 3 weeks, up to 3 weeks of age of life, the calf is generally considered as non-ruminant. Okay. Now per day 450 gram of milk replacer to be fed to the calf after mixing it in water at 38 degrees Celsius in a ratio of 1:7. So ratio of water is to, milk starter is to water is 1:7. 450 gram of milk replacer, sorry, not starter, milk replacer, and 7 parts of water. Okay. Now next is this table. So this table, feeding schedule of calf from 0 to 3 months of age. So age 0 to 3 days, colostrum at the rate 1/10 of body weight in 3 equal intervals per day. No calf starter, no hay. 4 to 15 days, milk at the, here was colostrum, here is now milk has started. So milk at the rate 1/10 of body weight of calf, no calf starter, no hay. Milk 15 to 21 days, milk at the rate 1/10 of body weight, again same, calf starter little amount and hay little amount. Next is 21 days to 2 months, 115 to 120th of the body weight of calf milk. So the milk is reduced. 100 to 250 gram calf starter, and hay is ad libitum, that is as much required. As much needed, we can feed it as much the animal requires, eats. Okay. Now age 2 months to 3 months, and no, milk has completely stopped here in 2 months. When we reach 2 months of age, milk has to be completely stopped. Calf starter 500 gram and hay ad libitum again. So this point came here. Rumen development takes place between 3 weeks to 3 months of age. Okay. Okay. So why do we feed for carbohydrates? This is a carbohydrate here. Why do we feed carbohydrates? So this is because rumen wall is plain at birth, and after 3 weeks it develops papillae. Okay. Now how does papillae develop? So due to carbohydrate fermentation, butyric acid formation takes place. So volatile fatty acid. What is the butyric acid? Volatile fatty acid. Its formation takes place, which leads to papillae development. Okay. Okay. Now absorption of rumen and other proportion of ruminant other stomach compartments. So in adult and newborn animal, so stomach in ruminants has 4 compartments: rumen, reticulum, omasum, abomasum. So reticular rumen in adult is 76%, omasum 18%, abomasum 16%. But look here, in newborn, reticular rumen is 38%, omasum is 13%, but abomasum is 49%. So abomasum is very reduced in adult animals. Okay, largely reduced. Okay.